Hey everyone, and welcome to this explainer. Today, we're diving straight into the SASB standards for electric utilities. We're going to figure out exactly how we track the localized pollution that's happening right in our own backyards. I'm really thrilled to guide you through this today because, well, we're looking at something incredibly tangible. We're going to unpack exactly how utility companies are required to measure, track, and report the specific air emissions that directly impact local communities. So let's kick things off with a crucial question, one that shifts our focus away from global climate change and points it directly at the immediate, localized air quality issues associated with electricity generation. I mean, we hear about greenhouse gases and global warming all the time, right? But if you live near a power generator, your immediate concern is much more likely to be the quality of the air you're breathing right now, today. So how do we systematically quantify that? Okay, let's draw a really clear line here between global greenhouse gases, which, by the way, are tracked elsewhere in the standard, and the strictly localized air quality pollutants that directly impact nearby communities. While things like carbon dioxide and methane mix into the global atmosphere, the hazardous byproducts from burning fossil fuels, stuff like sulfur oxides and heavy metals, they behave differently. They tend to settle into the local environment, creating severe, localized health risks. That major distinction is exactly why they require their own highly specific set of tracking metrics. And that is exactly where SASB metric IFAU 128.1 comes into play. This metric mandates the reporting of a very particular set of hazardous air pollutants. It isolates the exact air quality data electric utility entities need to disclose. Essentially, it cuts right through the noise and provides a strictly standardized framework for accountability across the board. Moving on to Section 1, Meet the Big Five Pollutants. Let's take a look at the specific lineup of hazardous byproducts from fuel combustion. Here is the exact lineup of the 5 critical pollutants generated by fuel combustion that electric utilities absolutely must report on to comply with the standard. First up, we've got nitrogen oxides, specifically NOx, excluding N2O. Then we have sulfur oxides, or SOx. Next is particulate matter, specifically PM10. And finally, the heavy metals, lead and mercury. Now, these aren't just arbitrary chemicals picked out of a hat. These are the most common, most impactful pollutants that create massive compliance risks for electricity generators simply because they are so strictly regulated. Now, you might be wondering about PM10, which is arguably the most technical measurement in our lineup. This refers to any airborne, finely divided solid or liquid material with an aerodynamic diameter less than or equal to a nominal 10 micrometers. To put that into perspective for you, that is just a tiny fraction of the width of a single human hair. It's so incredibly small that it can easily be inhaled deeply right into the lungs. And that for sure is why regulators and local communities care so deeply about tracking it. So, the real question is, how do we actually quantify these invisible threats? Well, the standard dictates that they must be comprehensively measured by their total weight in metric tons. The SASB standard requires utilities to disclose the direct air emissions resulting from literally all of the entity's activities. It's a uniform, heavy-duty measurement for a heavy-duty industry. This allows for a true apples-to-apples comparison across totally different power plants and utility companies all over the world. Of course, to accurately arrive at those metric ton figures, utilities can use a few approved calculation methods. The standard totally recognizes that you can't exactly just slide a bathroom scale under a giant smokestack, right? So utilities might use continuous emissions monitoring systems, which are often called SICS, physically at the stack. Or they might use advanced engineering calculations based on their specific fuel type and combustion technology. They can also use mass balance calculations. Actually, the main takeaway here is that whichever method they choose, it has to be rigorous, scientifically sound, and capable of pinpointing those metric tons accurately. Let's move on to Section 2, Tracking Near-Dense Populations, where we'll connect geographic data to human exposure. You see, it isn't enough to just report total pollution numbers. Utilities must also parse out the exact percentage of these hazardous emissions that are released in or near densely populated communities. Think about it. A metric ton of sulfur oxide emitted out in a totally remote, unpopulated desert carries a drastically different immediate human health risk than a metric ton emitted right on the edge of a major metropolis, right? The standard demands transparency on this exact intersection of pollution and population. To keep things objective, the standard explicitly defines an urbanized area as a densely developed location with a population greater than exactly 50,000 people. This gives us a really firm, quantitative baseline. It completely removes the ambiguity of what someone might consider a dense population, ensuring every single utility is operating under the exact same definitions when they calculate their exposure percentages. Furthermore, A utility facility is considered near a dense population if its physical boundaries fall anywhere within a 49-kilometer radius from that urbanized area. Because, let's face it, air pollution doesn't respect city limits. It drifts. So this 49-kilometer buffer zone constitutes the exposed population that is likely to come into direct contact with the air emissions from that facility. If a plant is anywhere within 49 kilometers of 50,000 people, every bit of its emissions counts toward that crucial percentage metric. Now, mapping this globally is tough. So to maintain strict standardization across the globe, the metric relies on specific UN statistical definitions and NASA spatial data to perfectly map those 49-kilometer boundaries. In the absence of perfectly accurate local census data, which, can be a huge challenge internationally, utilities are guided to use NASA's gridded population of the world data. It's a great example of how global sustainability standards leverage really high-level spatial data to enforce local accountability. Finally, let's look at Section 3, Why Quantifying Pollution Matters, Assessing the Financial and Operational Risks. If a utility fails to manage these air emissions near communities, they are staring down a cascade of financial risks. We're talking severe regulatory penalties for noncompliance, higher compliance costs across the board, and forced capital expenditures. Because these 5 pollutants are so strictly regulated, breaking the rules means massive fines. But even beyond the fines, if a utility operates near a large community and their emissions run high, regulators might literally force them to install incredibly expensive control technologies, like new scrubbers. In some scenarios, the capital required to update an older, highly polluting plant might actually exceed the value the plant generates, which effectively turns it into a stranded asset. Ultimately, though, by precisely quantifying and transparently reporting this localized data, utilities can proactively collaborate with regulators to effectively manage those looming capital planning risks. It isn't just about punishing companies. By actively tracking NOx, SX, PM10, lead, and mercury, a utility can essentially see around the corner. They can identify exactly which facilities pose the highest regulatory and legal risks due to their proximity to urban centers, and then prioritize their investments in clean technology accordingly. It's just smart business alignment with public health. So, as we see these standardized localized pollution metrics rolled out globally, they do something incredibly powerful. They strip away the invisibility of local pollution. By forcing transparent disclosure of what is being burned, exactly what is being released, and who is living within 49 kilometers of it, the SASB standards create a crystal clear picture. And it leaves us with one final, provocative thought to consider today. When the data is this undeniable and the financial risks are this thoroughly documented, who will ultimately be held accountable?